says the reaction between solid sodium iron and iron 3 oxide is one in a series of reactions that inflates an automobile airbag. So here they show you 6 moles of sodium plus 1 mole of iron 3 oxide produces 3 moles of sodium and 2 moles of iron. It says if 100 grams of sodium and 100 grams of iron 3 oxide are used in this reaction, determine the following: limiting and excess reagent. So the first thing that we're going to do is we got to figure out our limiting reagent. So it doesn't matter which one we pick, whether we start with 100 grams of sodium or 100 grams of iron oxide. I'm just going to go with 100 grams of sodium. And what we're going to do is we're going to say, okay, if I have 100 grams of sodium, how many grams of iron oxide will it react with? So I'm going to go from 100 grams of sodium into moles of sodium, into moles of iron oxide, and then into grams of iron 3 oxide. Okay, so I'm going to start with 100 grams of sodium. And on here, I have 1 mole of sodium being 22.990. So 1 mole of sodium is 22.990 grams of sodium. So now I'm in moles of sodium. Now I can go into moles of iron 3 oxide because I know for every 6 moles of sodium from my balanced chemical equation, I will react 1 mole of iron 3 oxide. Okay, and so now I can go from moles of iron 3 oxide into grams of iron 3 oxide and see how many grams of iron 3 oxide I will need. So let's see, oxygen is 15.999 times 3. And then iron, where's iron here? Iron is 55.845, so plus 55.845 plus 55.845 because I have 2 moles of iron. So 1 mole of iron 3 iron 3 oxide will weigh 159.69 grams of iron 3 oxide. So then my grams of sodium cancel out, my moles of sodium cancel out, my moles of iron 3 oxide cancel out, and I'm left in grams of iron 3 oxide. So I'm going to say 100 divided by 22.99. That gives me how many moles of sodium I have. Then I'm going to divide that by 6, and that gives me how many moles of iron I have. Multiply that by 159.69, and that gives me how many grams of iron 3 oxide will react with 100 grams of sodium, and that number is 115.7. We're going 4 significant digits, so that'd be 78 grams of iron 3 oxide. Now I know that I only have 100 grams of iron 3 oxide. And if I react all my sodium, I will need 100 grams, 115 grams, but I only have 100 grams. So that means that I will run out of iron 3 oxide before I run out of sodium. So my iron 3 oxide is my limiting reagent. Okay, so my limiting reagent is, I can say my sodium limiting is iron 3 oxide, excess is my sodium. Okay, so it says the mass of solid iron produced. So then I'm going to have to go here and say, start with my limiting reagent of 100.0 grams of iron 2 oxide. And so I'm going to go from iron 2 oxide, grams of iron 2 oxide into moles of iron 2 oxide, and then into moles of iron, into grams of iron to see how many grams will be produced. So I can say 100 grams of iron 3 oxides go into moles. So 1 mole of iron 3 oxide weighs 159.69 grams of iron 3 oxide. And so I know for every 1 mole of iron 3 oxide, I will produce 2 moles of iron. So for every 1 mole of iron 3 oxide, I will produce 2 moles of iron. And now I can go from moles of iron into grams. So every 1 mole of iron, and iron again weighs 55.845, weighs 55.845 grams of iron. So my grams of iron oxide cancel out. My moles of iron oxide cancel out. My moles of iron cancel out. I'm left in grams of iron. So I can say 100 divided by 100 divided by 159.69. Multiply that by 2. Multiply that by 55.845. That gives me 69.94 grams of iron is how much solid iron will be produced. Now the question is the mass of excess reactant. So I know that I will be short. I know that my limiting reagent is iron oxide, but I don't know, how much sodium I'll have left over. So what I'll need to do is I need to do this top equation backwards, but I need to start from 100 grams of iron to oxide and go into moles of iron to oxide, into moles of sodium, into grams of sodium. So I know that 100 grams of, or 1 mole of iron to oxide weighs 159.69 grams of iron to oxide. And I know for every, 1 mole of iron oxide, it's 6 moles of sodium. So 6 moles of sodium for every 1 mole of iron to oxide. And I know for 1 mole sodium weighs 22.990 grams of sodium. And so I can go through and I can say my grams of iron oxide cancel out, my moles of iron oxide cancel out, my moles of sodium cancel out, and I'm left in grams of sodium, which I want to be. So I'm going to say 100.0 divided by 159.69. Can't read my writing down there. Multiplied by 6 and multiplied by 22.99. And that gives me 86.38 grams of sodium. So I know that when I react all of my iron 3 oxide, I will only use up 86.38 grams of sodium. And I have 100 grams of sodium, so that means my excess reagent will have 13.62 grams of sodium in excess. Okay, so that's my excess reagent right there.